In this video, I'm going to show you some examples of how to simplify expressions with exponents. Okay, so I'm going to do 6 questions here, and these are the 6. I would encourage you to pause the video right now and copy these questions down and then give them a try and see how you do, just so you know how much you understand and how much you don't understand. Okay, so I'm going to start with A. We have b to the exponent negative 3 times b to the exponent 7. So in this case we have 2 powers and we're multiplying them, so we can use the product of powers rule. Which says these have the same bases, so we keep the base and we can add the exponents. So it's b to the negative 3 plus 7, which is b to the exponent 4. Okay. In the next one I've got 2.1 to the exponent 6 times 2.1 squared times divided by 2.1 to the exponent negative 10. So in this one I have 2 things going on. I've got a product of powers and I also have a quotient of powers. So I'll start with the numerator, and on the top, because I'm multiplying the powers and they have the same base, I'm going to add the exponents. So I'll have 2.1 to the exponent 6 plus 2 is 8, divided by 2.1 to the exponent negative 10. Okay, now I have a quotient of powers, so I'm going to have the same base, so I'm going to subtract the exponents. So I have 2.1 to the exponent of 8, and then carefully here, because it's 8, subtract negative 10. And that gives us 2.1 to the exponent, that's 8 plus 10, which is 18. And if that was sort of a nice friendly little number, like if that was 2.1 squared, we might evaluate that. If it was 2.1 squared, we might write down 4.41. But because this is sort of a ridiculous number, and it'll have a lot of decimal places, we'll just leave that as 2.1 to the exponent 18. Okay, on to the next one. We've got p to the exponent 4, all of that to the exponent 5. So this is a power of a power. So we'll use that rule that says we can multiply the exponents. P to the exponent 20. Okay, on to the next one. This one looks almost exactly the same. It's a power of a power, so we'll multiply to the exponents. We get p to the exponent negative 20. But when we say simplify, if we're asking you to simplify expressions with exponents, that usually means that you should write them with all the exponents positive. So this is much simpler than the first step, but for a final step in the simplification, if we've got something with a negative exponent in the numerator, essentially we just write it in the denominator. So it'll be 1 over p to the exponent 20. Okay, so the next one, we've got a squared, b cubed, and all of that is to the exponent 4. So here we have a power of a product, and actually both of the things in the product are also powers. But what that tells us, the power of a product, we can just sort of apply this exponent to both of those things inside. So we're going to have a squared to the exponent 4 times b cubed to the exponent 4. And now these are just powers of powers, so that's a to the 2 times 4 is 8. And b to the 3 times 4 is 12. Okay, and the last one here, f, is the longest. We've got 10a cubed b squared divided by 2a to the exponent 5b. And all of that is squared. So we can sort of start in different places. We could start from the outside and apply this exponent 2 to every single term in the entire expression. But it's not the easiest way to do it. It would be easier if we simplify the inside first and then square it. As long as you do it correctly, you get the same answer both ways. But it's usually best to sort of try to keep things as simple as possible. Okay. So here we're going to sort of deal with there's sort of three parts in this term. There's, I guess, the numerical coefficient parts, the parts with just the numbers, and then the parts with the a's, and the parts with the b's. So we can rewrite this as, I'm not really doing anything here. I'm just kind of separating out so it's more visually obvious what we do next. So 10 over 2 times a cubed over a to the exponent 5 times b squared over b. And all of that is just still squared from before. Yeah, so I didn't do anything, I just wrote it differently. So now what we have, it's a little more obvious what to do. This is 10 over 2, that's 5. And then a cubed divided by a to the exponent 5, that's a quotient of powers, so we can subtract the exponents. So that's a to 3 minus 5 is negative 2. And now for the b's, same thing, a quotient of powers, so we can subtract the exponents. But remember, b to no exponent, that's the same as b to the exponent 1. It's not b to the 0, right? Because b to the 0 is 1. So we'll subtract the exponents and we get b to the 2 minus 1 is 1. And then remember that all of that is still squared. Okay, so now I'm going to take my power of a product here. I'm going to apply this squared to everything inside. So I have 5 squared times a to the negative 2 squared times b to the 1, or b squared. Okay. And that's 5 squared is 25. A to the negative 2 squared, so it's a power of a power, so we multiply, is a to the negative 4 times b squared. And we're almost done here, except that we shouldn't leave a negative exponent in our final answer, just like back here. If it's a negative exponent, we should rewrite it as 1 over with the positive exponent. So this is going to be, so it'll be, in the numerator, we'll still have 25, and we'll still have b squared in the numerator. And then if I want to rewrite a to the negative 4 with a positive exponent, it's 1 over a to the 4. So essentially that means I just move a to the exponent 4 into the denominator. This flipping around your negative exponents to make them positive, I would suggest that you only do that in the very last step. I could have done that way back here, but I think sometimes it makes it more complicated than necessary if you do it early. Just leave them as negative exponents, and then at the very last step, anything with a negative exponent, if it's in the numerator, put it in the denominator, and vice versa. Okay, so I'll do some more videos with similar questions, but that are more complex, maybe looking more like F, because that's usually where people sort of run into trouble. So good luck with them.